Hi, welcome to an audio test session with APX. These videos provide worthwhile information for APX users and demonstrations on a range of audio measurement applications. In this session, Joe demonstrates some of the APX production test features.
In this audio precision video tutorial, we'll explain some of the features available to support automation and production test in the APX 500 Audio Analyzer Control software. Although these features are intended for production test, any users that need to conduct the same tests in a repeatable way will likely find many of them useful. The automation and production test features we'll cover in this video include aux control input and output, the pass-fail measurement, measurement sequence steps, APX variables, measurement sequence settings, pre-sequence and post-sequence steps, multiple sequences in a project, production test mode, and finally, we'll do a demonstration. First, let's look at the aux control input-output feature available in almost all APX hardware audio analyzers. This picture shows the aux control I/O monitor in the monitors and meters section of the APX user interface, just below the navigator. You're probably more used to looking at the scope or FFT monitors, but several other monitors are available, including this one. This monitor shows the state of two 9-pin digital I/O ports on the back of the APX 500 analyzer, one for input and one for output. The 8 registers in the upper row, labeled aux control out, are buttons that set the logic state of lines connected to the 9-pin aux control output port on the back of the analyzer. The 8 bits are set to 0 or logic low by default. The bits can be set here interactively by clicking on a button, or they can be set automatically by the sequencer. One common use case for the aux control out is to control the lights in a light tower. For example, if the entire test sequence passes, the sequencer could set bit 3 to high, turning on the green lamp in the light tower. The port can also be used to open and close external relays to turn devices on and off. The lower row of green on black indicators represent the state of the aux control input port. One of the 9 pins is a ground, and the other 8 pins each sense a logic level voltage. In this picture, nothing is connected to the aux control in port, so all 8 data bits indicate 0 or logic low. One common use case for the aux control in port is a foot switch, which can be very handy in a production test application where operators might have their hands full. For example, simply connecting the switch between pin 1 and pin 9 will set it to be monitored on data bit 1. When the switch is closed, bit 1 will change from 0 to 1, or from logic low to logic high. This can be used for a variety of purposes in the APX software. Measurement sequence steps are another useful feature for automation and production test. Every measurement in sequence mode in the APX software has a sequence steps node, which is collapsed by default. Clicking the plus sign to the left of this node will expand it to reveal the sequence steps that are present. Some things to note about sequence steps are, some steps, like the Measure AR DUT step, have a triangle icon. These steps are always present, and they are always run. This one runs the measurement, which in this case has been renamed to AR DUT. Some steps, like the Turn Generator On step, have a checkbox and are always present, but are only run if they have been checked. Other steps are added by clicking the Add Step node at the bottom of the list. Sequence steps with a checkbox are only executed if they are checked. The steps available in the list will change depending on the measurement context, the input or output connector selected, or the modules installed in the analyzer. For example, in the measurement shown, the list of sequence steps contains a set VDD output choice. This is a feature of the PDM module, so this sequence step is visible only if the analyzer is equipped with this optional module. Similarly, if the input or output was set to Bluetooth, sequence steps pertaining to Bluetooth configuration would appear in the list. Before we look at some sequence steps in an APX project, I first want to introduce the concept of APX variables. This slide shows the Variables tab of the Project Properties dialog, which is accessible from the APX project menu. A variable in APX is a name representing a string whose value may change depending on the circumstance. Variables are especially useful in specifying file paths accessed or saved by the APX software. The APX system variables shown on the right side of this slide represent APX-specific data. Their values change as the sequence progresses. Examples include device ID, typically used to enter the device under test serial number, signal path name, which contains the name of the current signal path, and project dir, which contains the file path of the folder containing the current APX project file. As shown on the left, you can also create user-defined variables. In this example, we have created variables to represent a golden unit ID, the device under test model, and the folder where data will be stored. Two additional classes of variables are available for use: Windows environment variables and Windows system folders. These are useful if you need to use standard Windows properties like the name of the user's PC or the folder path of the user's desktop. Here's an example of a prompt sequence step. The user is prompted to scan the device under test barcode, which will fill in the response field labeled ID and then automatically dismiss the prompt. In this case, the code entered is assigned to the APX system variable device ID. For the ID response, the required checkbox is checked, meaning the user must enter a value to proceed. In this case, the persist checkbox is unchecked, which will cause this field to be empty on the next sequence run. If persist is checked, the response field will be pre-populated with its value from the previous sequence run. For this prompt, an image has been used to clarify the instruction presented to the operator. The picture on the right shows a preview of how the prompt will look. As you probably know, signal path setup is a special measurement that is included in every signal path in sequence mode. Prompt steps in this measurement have some additional parameters for things like setting input and output references while the prompt is displayed, or for allowing the user to manually adjust the generator level during the prompt. An important use case for prompt steps in signal path setup is calibrating measurement microphones with a sound level calibrator. As shown here, when the input mode is acoustic, the Set dB/SPL checkbox is available in the Reference Levels section. The prompt instructs the operator to place a calibrator over the microphone, in this case an ear simulator microphone. A picture has been added to clarify the instruction. When the user selects OK, the system sets the microphone sensitivity so that levels can be correctly measured in dB/SPL or pascals. The Run External Program sequence step can be very useful for test automation. This example illustrates invoking an external program named setVoltage.exe to control a programmable DC power supply. The single argument is a user-defined variable named VDD, which contains the required voltage as a correctly formatted string. In this example, the program is a console application, or one that runs in a command prompt window. It is expected to return the string OK by writing it to the console. Here, the sequence step has been configured to wait for the program to exit and confirm that it responds with OK. In this case, if the external program returns an error message, or anything other than OK, the sequence step will cause the APX measurement and the sequence to fail. In addition to the measurement sequence steps that are part of every measurement, the APX Navigator has a set of pre-sequence steps that are run at the beginning of the sequence. This is where you would typically prompt the operator to enter the device ID, which is commonly used for the serial number. A device ID prompt is included in the standard APX project template, but it is unchecked by default. Any number of additional pre-sequence steps can be added here. For example, if you had a light tower, you could add a step to set the aux control out bit that turns on the tower's amber light to indicate the sequence is running. Similarly, there is a node at the end of the sequence for post-sequence steps. This section is for steps that are executed only at the end of the sequence. Default steps here include the APX report, which is checked by default in the standard project template, and the data output node, which is unchecked by default. We'll look at these two steps in more detail later. Every measurement in sequence mode also has a node with a gear icon titled Measurement Sequence Settings. Clicking on this node will open a dialog where you can specify what happens when the measurement fails limits. The default is to continue the sequence, which just flags the measurement as failed. Alternatively, you could have it cancel the sequence immediately, prompt the operator to retry the measurement, or automatically retry the measurement for a specified maximum number of retries. Because signal path setup is a special measurement, its measurement sequence setting node has some additional settings that are important. For example, as shown here, you can copy the references from any signal path in the project to the current signal path. This is handy, for example, if you have the user calibrate a microphone in one signal path and you need to use the same microphone in another signal path. The Measurement Sequence Settings node in Signal Path Setup also has a checkbox to run the Auto Set Generator Level feature. This is useful if you need to regulate the generator to a certain level, for example, the level that causes 1% distortion, sometimes called the clipping point. It's also useful if you need to calibrate the acoustic output of a loudspeaker. Another key feature to support production test and automation in APX is the ability to have multiple sequences in a project. The standard APX project template has one sequence named Sequence 1, but you can have many sequences in the same project file. A sequence is really just a collection of different checked items, measurements, results, sequence steps, and signal paths within the same project file. This slide shows 3 sequences in the same project file named Calibrate, Golden Unit, and Test Speaker. When a sequence is selected, only its checked items are executed when the sequence is run. This ability to control what parts of a project are run is an important feature for a way of interacting with APX audio analyzers called Production Test Mode. As shown here, if you click on the button with the lock icon to the right of the sequence selector, you are presented with the Lock Project dialog. Entering a password will enable you to lock the project. When the project is locked, the operator is prevented from changing any critical test parameters such as generator levels or test limits. When the production test checkbox is checked, in addition to the project being locked, the operator's interaction with the system occurs via a simple modal dialog with a few menu buttons as shown on the right. Note the buttons labeled Calibrate, Golden Unit, and Test Speaker. There is one button for each sequence in the project file. When the user clicks a button, the corresponding sequence is run. The production test dialog sits on top of the main APX user interface window if it is visible. If you think the normal APX user interface is too complicated for the test operator, you can elect to hide it in production test mode by simply unchecking the Show APX Application Window checkbox in the Lock Project dialog. To create new sequences, or to edit existing ones, click the button with the gear icon to the right of the Sequence Selector control to bring up the Edit Sequences dialog. Here you can select settings for each sequence in production test mode, such as the behavior when all measurements pass or when any measurement fails. You can also configure aux control I/O settings for each sequence, as well as a log file to record the values of variables and statistics each time the sequence is run. This slide shows the production test interface when the sequence is running. There is a customizable banner at the top. The middle section lists the measurements as they progress, with a pass-fail indicator as each one is completed. If the option to log variables and statistics is enabled, statistics such as the cycle count, number of items passed count, etc. are shown above the progress bar as the sequence progresses. Next, we'll do a demonstration. To demonstrate these features, we'll be using the small headphone amplifier shown in this photo as a device under test, or DUT. This device makes an ideal DUT because it is small and simple to set up, and it has some interesting features from an audio test perspective. The product's logo has been covered in the photo because the intent of this video is to demonstrate production test features, not the performance of the device. This headphone amplifier is battery powered. It has one analog input and 2 analog outputs, presumably so 2 headphone users can listen to the same content simultaneously. Controls and indicators on the device include a knob that doubles as a rotary on-off switch and a volume control, an LED that turns blue when the battery charge level is adequate and red when it is not, and a 3-position slide switch for the bass boost or equalizer feature with settings of flat, M for medium, and H for high. Here's our demonstration for the headphone amplifier test. As you can see, we're running in production test mode right now. We have the simplified user interface here in front of the main APX UI, and it has 2 main buttons on it, Test Output 1 and Test Output 2. These correspond to sequences named with the same name in the project file. Let's go ahead and run test output 1, and then we'll run test output 2. We'll then exit out of production test mode and break it down. All right, so here we get a prompt to enter the product ID of the device under test. I'm just going to type in ABCD999. Next, we get a prompt to scan the barcode of the device under test. I don't have a barcode scanner here, so I'm just going to type it in with the keyboard. 1234001. Next, we get a prompt telling the operator to switch on the device under test, to insert the cable into the headphone output jack 1, set the boost to flat, and to adjust the gain. So I've just switched the unit on, and you can see here we're watching the gain increase towards the target as I increase the volume control knob. And once I get into the target zone of plus or minus 1 dB, the colored bars change color, indicating that they're within limits. Once I've adjusted the gain, I can dismiss the prompt by clicking OK. Next, I get a message telling me that the system will set the generator level to the level required to produce 1% THD plus N. This is a regulation step using the auto set generator level feature. When it's finished, it'll progress to the next step. This is a pass-fail step, which is just asking the operator to verify that the LED on the front of the unit is the correct color. It is, so I'll collect pass to keep going. Next, we're running a level and gain measurement, comparing it to limits. Then a distortion measurement, THD plus N. Next, we measure a frequency response with the flat boost at 1 volt RMS, and the same measurement at 1% THD plus N. For the next step, we want to measure the frequency response with the boost set to M for medium, so I've got a prompt to set the boost to M. Once the boost is there, I click OK to continue, measure that frequency response, and the next step is the same for the H position. I switch the DUT to the H position and click OK to continue. Now, as you can see here, the system is progressing, and I get an indicator on the user interface for every time the sequence is passed. Now, what's happened here is it's automatically stepped to the next device under test because I've told it to do so. The other thing that you might notice is that the product ID field here is populated with the previous value. That's because I used the feature in the prompt to set the this input to be persistent across various tests. Go ahead and set that and get ready to scan the barcode. I'll just hit 1234002, continue, and so on. So the test carries on as it's doing now. So rather than keep going like this, I'm just going to cancel out of it so that we can carry on with the demo. So you'll notice when the sequence has been canceled by the user, the progress bar gets this red notification saying it's been canceled by user. At this point, we'll just end the sequence and go back to the main panel. Next, let's have a look at the Test Output 2 button. See what happens here. So we have a similar prompt. This time it's telling me to insert the input cable to the analyzer into input 2, and to set the gain. Gain setting is pretty much the same for the second output. Just adjust it a tiny bit and click OK to continue. Then we'll progress and measure the level and gain without doing the regulation step. Notice here that I didn't change the frequency response to flat, and it's caused it to fail the measurement. Here I will set the boost to the M position and click OK to continue. And next we'll go get a prompt to switch to the H position and continue with the measurement. So as you can see here, when I get to the end of the sequence, rather than going on to the next device automatically, it's been configured to just let the user do that manually. I'm also getting an indication that the sequence has failed, and in my list of measurements here I can see the measurements that have failed because the EQ wasn't set to the correct value. Let's go ahead and end the sequence here, and we'll break out of production test mode and look at how this project file is put together. So to get out of production test node, I can either press the unlock button, which unlocks the project, or the exit app. Exit app will simply exit the APX software. Let's try the unlock. If I type in the password, very simple password, and here I'm ready to look at the project. So let's go ahead and look at the sequence editor, and you can see here that I have two sequences, one labeled test output 1 and the other labeled test output 2. And these names, of course, correspond to the buttons that were on the front panel of my production test mode UI. I have the settings here that when the sequence, when all measurements pass, the sequence should run again automatically without pressing the next device, and set up for a number of retries. I also have selected the write variables and statistics to log file with a name of a file using variables. And let's just go in and look at some of these variables. So we have the folder is the project dir, which is the folder containing the APX project file, followed by reports underscore the product ID. That's the name of the folder, and then the file name is apx sequence statistics.csv. And if we look at test output 2, you can see that here we were set to have the sequence run again when the next device is pressed, not to automatically go to the next device. Let's close this and go and look at the way some of the other properties that we have here. So if I look at the sequence test output 1, you can see the collection of check boxes is different than it is for test output 2. If we go back to test output 1 and drill in a little bit, let's first look at some of the pre-sequence settings. So here we have the prompt. If we double click on this, we can open it and edit it or look at it. This is the prompt to enter the product ID of the device under test. We're assigning the product ID into this variable product ID, named product ID, and it is both required and persistent, meaning it must be present if I want to proceed, and the next time I run it will be set to the same value as it was before. We can also preview that. The next prompt is the device ID prompt. In this case, I've just got the text to scan the .bar barcode. In the appearance section, I've added a picture to make it clearer for the user, and again we can look at a preview of that prompt. If we look down at the bottom of the sequence, you can see the post-sequence steps. We have the report, and you'll notice that the report is checked here, but it wasn't showing up at the end of the sequence. So if we double click on that, we can look at the properties of the report, and you can see some of the settings here. So what we've done is we've used the Auto Save tab, and we've set the report up to automatically save the report when the sequence is completed, but the Show Report checkbox is unchecked, meaning that it will be saved automatically, but it won't show at the end of the sequence. Here we select the format. We've just chosen PDF for this report. We've used variables, again the project dir variable, followed by reports and then the product ID. We're using a prefix of HAMP and then the sequence name. And then we've set, if the report file exists, make a new file with a unique name. This second node here is the data output node that we discussed earlier. The way this works is if you select its properties, using variables, you can specify, again, the folder where the sequence data.csv file is saved. And let's go in and look at that folder. So if we go to, it's on the desktop here, PT demo, and that's the name of the folder we created using variables. If we drill in here, we see the APX sequence data.csv, and this is essentially just a CSV file that we can open with Excel. My Excel file doesn't open, Excel implementation doesn't open files automatically, so I have to do this extra step. This has the sequence run listed. We have the date and timestamp. The time will not be formatted correctly by default, but if I select time as the format, it'll set the time. Here you can see the device ID that's been filled in, a pass for the sequence, and then for every measurement that has a meter result, we get the name of the signal path and measurement and the channel, the upper limit and lower limit, and then for each run of the sequence, the measurement of that meter result. So this is a very nice way of logging the meter results as the project progresses and as you run multiple items. You can look at an entire day's or an entire week's worth of production using a spreadsheet like this. Now if we go back and look at that same folder, you can see the test reports here, and we get an indication, the product ID, the device ID, and then a summary field, summary area showing which measurements have passed, the entire sequence has passed, and all of our results that are present in the project, including the graphical results and the pass-fail indicators. We also have the APX sequence statistics.csv. Now this is generated because of the checkbox that we checked in the production test menu. And this keeps a log for every sequence run. Again, because of my Excel issue, I have to drag that folder in. So here we have a date and timestamp, the product ID, the device ID, the cycle count, the number of past count, the failed count, and so on. So whatever statistics that I've set up to be logged in this file are recorded on every sequence run. All right, so let's go back and look at some of the other settings in the project file. Now in signal path 1, we asked the user to set the gain of the device, and in order to do that we took advantage of this step called make result visible. So this is a sequence step, a very simple one. You just give it a name and you choose the result that you want to make visible. So that makes the gain result active so that the user can set the gain. I've also checked this turn generator on step. This is a step that is available all the time, but it's unchecked by default because I want the gain to be on, I want the generator to be on so that I can measure the gain and have the user set it properly. Then we have the prompt to set the gain, and just as a preview here, this is the instruction that we gave the operator with the gain showing on the screen so that we could have him set the correct level. Then we have the result visible. We make the THD plus N ratio result visible. And then the very next step is a prompt that we're setting the generator to 1% THD plus N on channel 1. Now this prompt doesn't have any response, and it only shows for 2 seconds. So really this is just to advise the operator that we're doing a regulation measurement. And let's have a look at how we're doing that. It's not through a sequence step in this case, it's through the measurement sequence settings. So if we click on this node, we can see that for signal path setup, we have this checkbox, auto set generator level, and it's been checked. And this will cause the system to regulate and run the auto set generator level feature. That feature is available in the References tab down here under auto gen level. So it's been pre-configured in the project to regulate THD plus N ratio to a target value of 1% on a specific channel, being channel 1. And we have the start and stop value, the initial steps, and the frequency that we want to regulate at. So essentially we're telling the system to regulate to 1% THD plus N on channel 1. When that process is complete, if we look in the Verify Connections tab, the generator level is left at the value required to achieve the 1% THD plus N target. It also sets what we call the DBRG reference. This is the value of the reference now required to produce 1% THD plus N. Now that we've done that, if I go back to a measurement such as this one, where I wanted to measure the frequency response at 1% THD plus N, I can simply set the generator level in units of DBRG, 0 DBRG being the target required to get 1% THD plus N. That's a quick demonstration of production test mode and the production test features in the APX project file. Hope that you'll find some of these features useful, and thank you for watching.
Thank you for joining us for this audio test session with APX. For additional videos, visit ap.com or any of our social media channels.